ఇవ్వలేదు మైక్. Right. So in previous algorithms on pat trees, right? So what are the algorithms on pat trees? Searching. Second one. Long. What about the remaining word? Longest. Searching. Most frequent searching. And last one is regular expression. Except the last one, we have completed the writing of all the 5 as well. Okay? Right. So in today's class, first we will see we will try to wind up. We will write the part of your notes. Okay. So first listen carefully, then we can go for the writing part. Right. So next one we are having building batteries as batteries. Okay. So as our next concept. Get into what is building the pat trees as patrician. Then we will go for pat trees as arrays, and then we will see how the representation of arrays is going to be. Okay. So the implementation of pat trees using conventional is the obvious, except for the sum of the implementation or it's accessing time quietly dramatically. Okay. So since this type of index is typically built over the size of the index tree is linear in the size of the text and economic is mandatory. So when you are going for building a pat tree, we are speaking in terms of its size, we are speaking in terms of its capacity, that is its size, how it is going to behave, that is it going to accept or not, how it is going to give us the results that we are going to see over here when we are going for building a patricia tree, when we are trying to build from pat trees. Okay. So is already available for the users, right? So it cannot be done doing with the increase of the size. So whatever the things that are doing with the new patricia new is converting whatever the of okay. So since this type of index is typically built over very large databases, so we are having large text databases. So having a limited text database, it is very fine for building batteries, building digital trees, building unit trees. That is fine. So when you are having large text, we are going beyond the limit, then our patricia trees are coming into the play, and we are going for this particular patricia trees. Okay. And the size of this index tree is linear size. We are going to build these patricia trees, so the size has to be in linear model, that is linear in size. that is with related to the text, and it has to be in economy with the users, or economic is mandatory for the users to build particular patricia trees. Okay, so it is easy to see that the between 3 and 4 words size. So now we are getting what is word size. Okay, so previously we are speaking about the size. Previously we are speaking about the database, that is how the database has to be, how the size has to be, that is linear in size or something else is there or anything other is there, that we spoke in terms of in the first paragraph. That is how the implementation is going to be, that we have spoke in terms of size, in terms of its database capacity. Now we are coming to a conclusion, or now we are giving in detail what is the word size when you are going for your patricia tree. Okay, so what is the so each external node can be a word. Consequently, we are taking between 4 to 5n, that is 4 number to 5 characters, indexing characters, most likely unacceptable from the practical point of view. Okay, so what is the maximum size? It can be acceptable 4 to 5. So it is not going to accept 18 characters. If it is exceeding 18 characters, it is not going to accept. Then secondly, the organization of the tree should be such that we can gain from of large records. Okay, so how we are gaining? We are gaining it from the large records. Whatever the records that we are having, we are gaining the information from the large records. Okay, so that is the external files will use. So when you are thinking about the external node and the internal node, in between these things, so your size is going to be varying when you are going for drawing the patricia tree. Okay, so the main ideas is to solve both problems. So we are having two problems when we are dealing with your patricia trees, that is bucketing of external nodes and mapping the tree onto a disk using super nodes. So when you are going for a drawing or constructing your patricia trees, you are having two different difficulties. One is going up with the bucketing of external nodes. We will see what is the meaning of bucketing of your external nodes, and then mapping the tree onto a disk using super nodes. We will see super nodes, that how we are going to use our this patricia trees. Okay, so collecting more than one external node is called collecting more than so you should not have to see bucketing, that is you are having internal and when you are having external nodes, when you are collecting more than one external point of view, then it is called as bucketing, and is an old idea of data processing. So this is the old idea of data processing. So in bucket replaces any subtree with size less than certain constant, say that is called B. So your bucket is going to be less than particular A, and hence saves up to B minus 1 internal nodes. So B. So however we are taking those many nodes, we are that is so the external nodes is external nodes inside the bucket do not have any structure stated in them, and which has to be all the numbers of the bucket. So this external one is sorry, this internal node to be going to be having something to be played. So this increases the number of comparisons for each search. If you are selecting your values, that is keys, buckets. So these buckets, that is extra row, are going to save the internal node. Okay, that is the general buckets is necessary to complete all the, and an average number of bucket is b by 2. So in most of the most field, b by 2 number of buckets. About n by p by 2 internal loads. It is having b value itself. That is how many internal nodes and external nodes are there. Those many things are available for the internal nodes. But whereas comparing with the external nodes, you will be having only b by 2 of the bucket filling. Okay, so this means that the a factor of b by 2. Speaking when you the external okay. So of between time factor and the space factor, that is how the time is going to be for this particular batteries and how we are going to take up with the space complexity, that is how much space is going to be accepted in this particular tree structure when you are going for this particular one. Okay, so the main allocate as much as we preserve the unit, right? So what we are going to give, going to give the unique page numbers. As long as we are getting unique page numbers, we are going to give unique keys and unique particular values. Your points are going to be every page. So has single entry as much as 3 possible and terminate external nodes. So how many will be having 3 factor, then your space contains as 3 points and you will be, that is 3 possible sizes terminates in internal node, that is external node is going to point to the address either the disk page or another node in the same page, that is this page or another page in the disk space it is going to okay. So this right is last is it వస్తుంది last is it audible? Yes or no? Be silent. Is going to be, that is So we are discussing about the pad trees, that is building pad trees. How to go for the building pad trees? What is the need of going for these pad trees? Less database with less. Is it necessary for building us with patricia trees, or we are comfortable with pad trees? When your size is limited, when you are having that is your digital trees you can build. So when you data is increasing, or you are having large databases, to be built, then you are going with this particular patricia trees. So that is what we are speaking in terms of pad trees and patricia trees. Large database, you are going for this particular patricia trees, that is mentioned over here. Okay, that point is mentioned over here. Okay, so this type of index is typically built over large text databases. What we are saying, this patricia trees is going to be built over large text databases. When you are comfortable with less text databases, you will be comfortable with pad trees. When you are exceeding your text size or text database, you are going with this particular implementation or large text databases. So we are having, so what is the size should be? The size of the index is linear with respect to the text. So which is going to accept how many characters, that we are deciding in the next paragraph. We are going to decide on the what is going to have 3 to 4 characters or 4 to, okay. So each line or each word is going to have 3 to 4, sorry, each internal node is going to have the 3 to 4 words index. Okay. 4 into 5 as the process. So if you are deciding this particular one, so it is not going to accept more than 18 characters. Just like when you are going to give your passwords, it is going to take up to 12 characters, or so when you are status, or when you are trying to write some text, in some cases you will be restricted with 18 characters, right? So similar case here also we are having with the patricia trees as 18 characters. So if you are having, then your search is not going to be done. So second case is, the first case is you are having 3 to 4 words or 4 to or characters, that can be acceptable, right? So if you are exceeding 18 characters, it is not going to accept as internal loads and as external loads when you are trying to draw the patricia trees. Okay, should be database. So wait for your large size, and it has to be accepted by the users, right? And it should not be more than 18 characters. The second case is when you are going for organizing, or when you are going for, you are having two different issues. Two factors we are going to solve. That is, main ideas is solving both problems. We are having two different problems. We are having the first problem as bucketing. Okay, bucketing of external nodes, and the second one is mapping the trees onto the disk using super nodes. So what do you mean by bucketing? What do you mean by bucketing? What do you mean by bucketing? That we are discussing over here. So when you are be having all over there within the restricted point or any nodes even after your restriction or even after your collection, or if the restrictions are also not there, but still if you are getting any of the nodes as external nodes. So even if it is having restrictions or not having restrictions, if you are having internal nodes and external nodes, when you are collecting more than one external node, then it is said to be as bucket. Okay, this particular node is said to be as your whole item. So one bucket, or if you are going to be, what we are going to do, so we are going to go with the, so how we are going to replace, so replaces any with the help of your two. If you are starting from B, you can reach up to, you can reach up to, the buckets or replacement subtree is taken as B. So when you are taking B as your subtree, your value is going to be, that is constant value is going to be less than B minus 1. That is whatever the value that is searching is going to be, okay. So then the external nodes is, now we are of the internal nodes. So the external nodes inside the buckets do not have any structure associated with it, and any search which has to be done in the bucket has to be done of the that you want to make between all the buckets. Then only you will be getting your complete that you will be getting. Okay. So this increases the number of comparisons for each search. So what we are having n values, that is n nodes attached with your external node, that is bucket. So when you are going for search, it is searching from starting node till last node. So it will come over here first node, then second node, third node, fourth node, fifth, 5, 6, 7, 8, 9, 10, like that it is searching. So when you are searching each and every node which is available in the tree or subtree, comparisons are increasing. Okay, so when your comparisons are increasing, so your worst case options are also going to be, right. What we are saying, the increase of the number of comparisons for each search, in worst case you are taking over here, if you are taking your value as, your worst case option is B. If you are taking as a, your worst case, if you are taking your worst case is, because you are going to search for each and every node. So on the other hand, that is, on the other hand, what it is having also random distribution. So when you are having a fixed distribution, that is worst case B. don't have any prescribed structure. We will be having n nodes as n by 2. Okay, you will be having n nodes, but it is in terms of, you are having B, you will be having in terms of, you won't be knowing where your nodes are located or your internal nodes and external nodes. If you are getting any bucket of B2, that is B by 2, so that is your randomized bucket, right? So you are getting your randomized bucket. So what is the worst case that you are going to get? It is going to be, if you are taking n values, it is going to be n by B by 2. Nodes first, when you are having random strings, it is going to be B by 2 or K by 2 or n by B by 2. Okay. But it is clear so far. Pat trees as Patricia trees, when you are having fixed length and when you are having variable length, that is where what is the value that is string length or what is the having what is the value? What is the bucket size and what is the search size? Size or variable when you are having size, when you are having the size n by 2, what is required? We have to understand anything or we have understood see, concentrate for, then it will be easy for us. Okay, so there is nothing in this particular concept. First tell me, if we have bigger Patricia trees, is it going to be large databases or large databases? So when you are having when you are size, so how size particular nodes or the Patricia tree has to be in terms of size? In terms of size has to be. So if you are taking n values, your last node is n is your variable size. So what is your last variable size? N minus 1. You are taking it as B, K minus 1. That is clear. That is having root node starting from 1 to n we are drawing. Okay, so 1 to n if you are having your size, then 1 to n minus 1 we are, it is going to be done for the clear. So when you are having this kind of thing, right, so you are having two different problems. You are having this kind of of bucketing, which is called as getting more than one external load is you are going to get. So that is the first problem with this particular database. Second one is mapping the tree onto the disk using supernode. So first case is getting more than external load. Second case is getting disk space. That is mapping the tree onto the disk using supernodes. Okay. So up to here, this way is clear. Size. So when you are going to have the size, you will be having 3 to 4 words. That is your node size is maximum of 3 to 4 characters. 3 to 4 characters. That is 3 to 4 words you will be having. So it is not going to exceed 18 characters. Size is not going to exceed 18 characters for a single word. So if you are exceeding 18 characters, then it is not going to accept. That is going to be the case in your pattern. Okay. So that is first point. Second point is we are having two problems. One is with bucketing, the other one is string. That is mapping onto disk space or mapping onto the space. Right. So here we are giving the complete idea of bucketing. So what do you mean by bucketing? One more than one external loads. Okay. So here we will try to right. So having and leaf nodes also we are having. So when you are reaching to the final load, you are having, if you are getting any all this load some size, right? So we have given numbering 1, 2, 3, 4, 5, 6 up to 9 we have given, or up to 10 we have given size. So we have given 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, something example we have given, no? For some tree we have given that kind of structure. So here also we have plot. Okay. So there we are getting external loads. Where you are having the particular tree kind of structure, you are also having one limited case in one of the diagram. Okay, in one of the diagram, right? So you are restricted with some portion, and if you are exceeding that portion, you are going to get extra portion, right? So even if it is there or not, what is our intention is you will be having one external load. So that is the one external load, that is the old version of data processing as patries into patricia trees. That is one case, right? So if that is going to be happening, then what we are going to do? So in older version, what we are doing? So if you that is right? So that is the root node is known, child nodes you don't know where exactly they are coming, right? So if that is going to be if that is going to be the string length, then what is your fate? What is the size of the structure? So when your size is fixed, you are having b minus 1, k minus 1, n minus 1. So if your size is dynamic, that is external load size is dynamic, then length is not fixed. So external nodes inside the bucket do not have any structure. So when you are having fixed length load ఉంది, దానికి structure ఉంది, when you are having that is external loads inside a bucket do not have any structure associated with is having any fixed structure. So say for example you are having root node over here, child node, child node, child node. So this is increasing from 1 to 1, but other side it is not getting. So this portion can that is external load by dynamic length. Dynamic length your nodes are increasing. Side is not completely increasing or it is not coming properly. Then what is the size? Complete bandwidth is available? No, right? So how much it is available? How much half of the portion only available, right? So then size, your size. So if you are taking it as n, it is going to be n by 2. If you are taking it as b, it is going to be b by 2. If you are taking it as j, your size is going to be right. If you are having your values randomized, your values are by 2. That is half of the portion is going to be available. That's what we are trying to say. Okay. So if this is going to be the case, what is the worst case of such thing? So if this is going to be the case, n is going to be the size. Your worst case option is n. So when you are going for n by 2, your worst case such is for this one it is, if you are saying it as n, the worst case option of such thing is n. So what about this one? This is going to be worst case of such is ఎన్నిసార్లు వెళ్తారు n by how many times you are going to go for such? N by 2 only, right? You are starting from 1, you are reaching up to n by 2. That is half of the portion only you are searching, and you will be getting your final result. Right? So right. So that is what we are saying so far. Right. So when external nodes inside the bucket do not have structure, so when you are not having any structure, that is partially filled or outside filled or any side is partially is going to be filled on both ends, then the size is not going to be fixed. That is not filled. So any such which has to be done on the bucket has to be done on all the members of the bucket. So in this, what is happening? It is increasing the from 1 to some you are checking with your values. So that increasing your time consumption. Okay. So when you are having fixed length, your time consumption is less. When you are having variable length, your time consumption is okay. So buckets are significant number of internodes. It is not possible to have all the buckets full. Okay. So when you are having randomized one, it is not possible to fill all the when you are having n by 2 at the most you are going to fill n by 2. If you are having, you will be filling. Okay. So on an average number of keys per is not having, you will be having when you are having. Okay. So hence instead of n minus 1 nodes, we have about n by b by 2 internal nodes for random strings. So random from 1 to b by 2. Your values are from n by b by is b by 2. 1 by sorry n by b by 2 is our randomized value for this particular tree. That is buckets. Okay. So this means that the overhead of the internal nodes which are part of the index can be cut down by a factor of b by 2. Right. So how we are cutting with the help of b by 2. That is half of the portion filled or partially it is filled. Right. So we have then a very simple trade-off that is time factor we are speaking. So what is the time factor that is required and what is the space factor that is required for organizing this type of nodes or super nodes, we will see. So organizing the tree in super nodes has advantages from the point of view the number of access here. Super nodes as well as the space, that is space you will be having super nodes. When you are having super nodes, that is the nodes can be added or the nodes can be replaced for whenever you are required, then these are going to play the major role. So the main idea is simple: we allocate as much as possible tree or in disk space as long as we preserve unique entry point for every page. So when you are having a unique page or this the data based on your requirements. So when you are having de facto factor and this page has single, you are going to have a single entry point that contains the access on disk pages only. Okay. So which is going to have the access on this page. Okay. So again it is going to have as much as possible and pointers. It's going to accept the pointers, nodes, internal nodes, right? So every information is going to be stored, and when it is coming for the external node, it is going to be going with the disk pages. That is, it is going to terminate the external disk pages. That whatever we are over here, it is going to be terminated with the help of super nodes. That is adding more nodes or external nodes. Will address either a disk page or another node inside the same page. So the pointers are going to point the disk page or other nodes within this particular disk page. Okay. So that is the consequently can be substantially smaller. That is, it is going to be smaller than this value highest value. So unfortunately, not all disk pages will be. So it's not going to be 100% full. So a bottom of 50% of occupation, that is a bottom up, that is from filling up your values or the nodes from bottom to top is going to fill you up with more than 50% of data. Okay, so experiments indicate the close to the top node in matrix tree up to 80%, but not 100%. Okay, so with these constraints, this this means that on the average each disk page will contain about 10 stages of root to leaf path. So how many pages you are having? That is root to path, that is root node to the leaf node, you will be having 10 pages at the maximum of 10 pages. Okay, so or in other words, the total number of accesses in 10 of we are having size as 1 to n, we will be having height of the ring, that is 1 by 10 of your height of the ring. So since we need to keep the root bit to the memory, this has this. So when you are keeping this kind of thing, you are going to get with the 2 to 3 disk access, because we are keeping the values of height, that is prefix is already available. So what is the size that is also available? 3 to 4 maximum. So when you are keeping this 3 to 4 fix, right? So when your prefix search is there, you will find your easiest. Okay, so this means that the typical prefix and what so this implementation is the most for this type of search. So finally, comfortable with the disk access, that is among these two types we are comfortable with the second one, that is mapping of the tree onto the disk using super node. Okay. So tarvata, what you are mapping the tree onto the disk using super nodes. So when you are speaking in terms of your bucketing, how many extra nodes we are getting, how many we are getting, that is buckets, more than one bucket you are getting. So is fixed, what is the final length, that is what is the final worst case. When the length is fixed to n or b or k, what is the worst case? It is n minus 1, it is k minus 1, it is k. When you are having random values n by 2, that is half of the portion or partial of the portion is filled, remaining portion is empty. So for that we will be coming to a conclusion of half portion is completely filled or half of the portion is going to be searched. So that value is going to be indicated with the help of n by 2. Okay. So case is we are having n 1 to n values. If we are having one case option for random variables, that is for random filling. For random filling, what is the value? Worst case. How many internal nodes? N by p by 2 is your internal loads for random strings. Okay, that is good. So then will be in terms of your super nodes. So what is the role of your super nodes? Hey, how many entry points are there? How many entry points? మా డయాగ్రామ్ ని ఇలా చెప్పినానా, ఇట్లా చెప్పినానా, ఇట్లా చెప్పినానా అమ్మా? So which one I have drawn? One or two when I was explaining. First indication or second indication? First indication. ఇప్పుడు చెప్పండి. ఫస్ట్ వన్ సెకండ్ వన్? ఫస్ట్ వన్ సెకండ్ వన్? What is the reason? What is the feeling in your super nodes? Top to bottom or bottom to top? Bottom to top. So what is the percentage? Maximum of 80%. Okay, more than 80%, but it is maximum of 80%. Okay. So up to the root node, not up to. Okay. So your entry will be on the top, the values will be loaded from the top, but your filling gaps or filling values will be from the bottom to top. Okay. So that is related to the batteries as battery checklist. Clear? One is clear? One is clear? So shall we move on to the next one? Building. My shall we move on to the next one? Okay. Right, Ram. Next we will see pad trees represented as arrays. Okay. So we have seen so now we will try to see the representation as arrays. Okay. So the representation of pad trees as arrays. Let us see right now. Okay. So the previous implementation. So prefix you are having in your pad trees that you have searched your complete text complete effectively. Okay. So that we have seen. So here you are having that right. So next one is the previous implementation prefix values, right? So the external bucket we have to scan the external bucket to determine if the bucket is full or this cost becomes prohibitive. Okay. So however, if the internal nodes in the bucket are kept in the same relative order as they would be in the tree, then we do not need to do anything. So ఇలా అయితే ప్రాసెస్ లో అలా పెట్టేసి మనకు చేయడానికి ఇబ్బంది లేదు. So when you are going or when you are keeping your values as separate or when you are keeping your values as randomized, then you are getting your values to be searched wider. Okay. So we go out to find the nodes which satisfy the search. Okay. So when you are having sequence values in order, you are having a complete search from when you are filling search from bottom to top. Okay. So that is not going to give us this. It is going to give us the better results. So consequently, the cost of searching is bucket becomes 2 log d minus 1 instead of top to bottom, and you need to search from your bottom to top. Both or and the cost is also going to be increased. The cost is increasing from that is when you are searching from one node to the last node, your cost is also going to be increased. Okay. So all these, this is not significant for all small buckets. It is crucial operation which allows or which allows another implementation of pad trees. Okay. So when you are search, then that is leading us to go for the better option. Okay. So any node or any bucket is So if it is taking more time, then you will be finding for the alternatives. So similarly here also we are finding for the alternate method. So that is making us, or that is leading us to the arrays. Okay. So this is simply including the option of letting it to be equal to n, equal to n. Okay. So if it is becoming 2n, we are making it let to n. External nodes ordered lexicographically by SI. All the arrays, that is we are making all the values in the form of arrays. Okay, that is in sorted way. We are having in unsorted, and this is also taking too making is taking too much space. It is taking too much time to reach or to search for the given value, right? So what it is doing. So the search time is wasted. That is, most of the time is wasted for the users. So to avoid those such kinds of things, and arrays. So where we are keeping the entire this particular field like structure information in the form of arrays, and it is going to be available for the users in the form of sorted. That is, arrangement is being done. So when you are having lexicographical arrangement, you will be having that is you will be having of information in a array. So when you are searching for an event, sorry, when you are searching for an element, you are searching very easy because all the values are ordered in lexicographical way. That is in ascending order, all the values are ordered. So when you are searching for a x value, you will be getting in so and so location. When you are searching for y, you will be getting in so and so location. That is in lexicographical. Okay. So with some additions, this idea was independently discovered by Manher and Myers, who called these structures as suffix arrays. So which was developed in 1990. So what is the motive? So when you are having your complete values, so those values can be represented in the form of lexicographical array. So where that is lexicographically. So when you are where you will be going, you will be directly moving on to. So by this, your time reduction is going to happen. So time taking for searching the particular element is what it is happening. It is taking too much longer of time because it is searching from top to bottom once again, and it is reaching from bottom to top. So it is coming. That is from root node to last node, and it is also coming from what is happening in time. So when you are we are moving on to your arrays. So you are representing your text or data in the form of Patrica arrays. Okay. So that data you are taking in the form of arrays. So what you are doing? So you are giving your values in ascending order. You are giving your values, whatever the three values that you are having over here, you are all giving all your values in the form of ascending order. That is in lexicographical order. So with this, what is happening when you are searching for the element 3, where your key is going to come, when you are giving element 3, you are searching for element 3 in an array. So where your element is going to come, where your keyword is going to come. So you are searching for element, your keyword is directly because you already arranged your elements in the ascending order. So with this we are reducing our time period, right? So this is the representation of how your path tree is going to be represented in the path arrays. Ma, clear? Up to here, this one is clear in terms of your space and time complexity. Clear? మా అర్థమైంది పోయింది అర్థమైపోయిందా పెట్టినారా రైట్ సో హియర్ దిస్ వన్ ఈజ్ అవర్ better example of Patrician as our arrays. Okay, so there is a straightforward argument. It shows that these arrays contain most of the we had in the Patrician tree at the cost of factor log n. So again having the argument. So what is having the argument? Size or structure you are having over here. This size or structure you are already having in the something. So what it is having? It is more further. The array is less time for search. So the factor of and for filling when you are so those discussions are going to be done and these arguments are for any which contains all when you are having a so when you are having elements when you are having elements so whatever the size of the elements are there that is n elements we are having the subtree of all those elements in this particular lexicographical arrangement as arrays. So the sizes of the subtree are trivially obtained from the limits of this size whatever you are having this can be get from any point of time that is any side of going top to bottom bottom to top you can go directly from that is starting location to the ending location or particular ending location to the this particular location we can move in arrays. That is the advantage. Okay, so the only information that is the longest that is so what is missing longest so when you are going top to bottom or bottom you are getting some values some longest but when you are going with the it is moving from first location you are searching for your element if you are searching from nth element if it is moving from 1 to n or n to 1 right? So this is happening. So if you are moving from 1 to n when you are searching for your nth element when you are searching from nth element sorry you are so you can search from back so that is last element first element you first element to last element. So when for your nth element it is searching from nth element to the first element but you are finding result in the nth elements itself. Longest is missing. Okay, first you are not going to search from nth element to the first element the result is found at nth element. Okay, so longest representation is possible represent without any additional structure in n log n axis. So the above figure is showing this particular structure. Okay, so that is whatever we are searching or whatever we are going for search. So when your values are fixed or when you are searching for so and so element you can directly get your element location in terms of your arrays. But in terms of your tree-like structure, you need to go from bottom and bottom to top for searching and filling the elements. Okay, that is the advantage, or that is the thing which we are going to have in terms of our arrays. Clear? This one is clear. My introduction part of this one is clear. Batteries. So why there is a necessity for going with arrays? What is the drawback over there? So from where to where the data is going to be filled? It is filling 80%, greater than 50% and 80%, maximum of 80% it is filling. So when you are looking for search, it is from even if it is one node, that is root node, and it has to end up with the end node, right? So drawback of time complexity. Then we are moving on to with the arrays. So in arrays, how they represent? In arrays, how we are using the same format of real-time data. So what do you mean by lexicographical? That is, you are arranging your values in sorted array. Okay. So when you are arranging the values in sorted array, okay. So when this is happening, that is when you are searching is completely filled, is good. What is that is string is going to be repeated or substring is going to be repeated. In arrays, we don't have the repeated string in arrays. Is missing in the representation. Okay. So to avoid that, that is to overcome that particular thing, what we are doing, missing in representation of your patricial trees as arrays. So what we are missing the longest repetition time. Okay. So for that, we have given this particular diagram of your trees as pattern. So what we are having a text which is in time, which is in terms of your lexicographical manner. So those text, that is this text, is again represented in the form of pat tree, that is ascending order. So if you are searching for a particular location, or if you are searching for a particular thing, that particular information is going to be searched very clearly. Okay. So that one is clear. Basic introduction to a searching. This one is clear. Pat trees representation as arrays. Clear? So shall we move on to the searching? How the searching is going to be? How the searching is going to be? Shall we move on to the next one? This one. So in this we are having this particular entire text into some multiple portions. Okay. So first one is searching for patries as arrays. So why it is not necessary and what is the need of? So let us see right now. Okay. So searching as everything is available in terms of your arrays. Okay. So when you are having it in terms of lexicographical, that is 1, 2, 3 up to n, when you are having some text as lexicographical, then what is the requirement of searching patries as arrays? Let us see right now. Okay. So it turns out that it is not necessary to get the patries for the prefix and algorithm which is order of n log n, sorry, order of log 2 searching, range searching become more uniform. Prefix searching and range searching is becoming more uniform. Both the with results of comparisons being less than or equal to 3 or greater than. Okay. Of the comparisons and it is going to give us the disk access. So the most frequent, but becomes too technical to falls outside the scope of this particular. This can be about the longest repetition. See, so what is searching patries is having the entire text. Right. So searching patries are having the text of information. So when you are having this particular thing, that is when it is represented in terms of your arrays. So when you are asked to search for a particular element, so how it is behaving, that is the matter over here, that is searching for matrices arrays. Finding your so if it is having more time, okay, so when you are representing it in terms of or range, you are having values and range, then so if that is going to be increased, then the search value is also going to be increased. If it's searching range represented in searching factories as arrays. Okay, so that is the three type complexity is represented. Okay, so next coming to building factories as arrays. So we can build the factories as arrays based on our lexicographical manner, that is from starting your alphabetical alphabet Z, so which is as that is auxiliary representation. So we can take from a bit to the Z. So when you are having this, that is when you are representing this in terms of your OED, that is Oxford English, you have to go from alphabet A to alphabet Z. So when you are from A to Z, that is your values are 1 to n, your time complexity is n, that is the part of n. From 1 to n minus 1, it is part of n minus 1. Okay. So when you are coming to the building of flat arrays in memory, so you are going to take the small portion, that is whatever the small portion of structure, and you are going to build the arrays in, that is you will be taking whatever the context is there for the user, you will be taking and you will be writing in the form of your chronological order A, B, C, D, and you will be filling in the format, and then you will be going for your building of this particular memory system, your computer system. Okay, then you are merging small against large batteries. So when your size is less and when your batteries are having less size and more size, then now we can go for merging those index or merging those index is our concept. So in this figure you can see is not merging. So we have this side and text and index is this side, and you will having the counters and small index again. So here it is extended index, here it is small index, right? So you are converting or merging it into the available data. You have to take the entry of index, you are going to take the words, you are going to take the characters, then you are going to go with the complete values. Okay. So why the delayed reading paradigm is going to happen is when you are having your size, right, and you are not able to reach from starting location to the ending location, you will be having your delayed in reading procedure, that is delayed in reading paradigm, that is you could not able to reach from starting location till the last location. Then merging large files indicates you are going to merge complete files or large files into a single file. Okay, so this is what we are having in your of your target as well. Everything is done. లేకపోతే ఎగ్జామ్ రాపించేద్దామా, మిగిలింది రాపించేద్దామా, ఎగ్జామ్ రాపిద్దామా? ఫుల్ టైం ఉంది సార్, ఫుల్ టైం ఉంది. టైం ఉంది 11 సార్, ఇప్పుడు అయ్యింది 11:10. ఫస్ట్ ఎగ్జామ్ ఆడికి 1కి కదా లంచ్, వీడికి 1 కదా లంచ్, వీళ్ళకి 1 కదా సార్ లంచ్. 10 నిమిషాలు అటు ఇటు వదిలేద్దాం. ఆ క్వశ్చన్ చెప్పాడు సార్, క్వశ్చన్ ఇచ్చేద్దాం, వాళ్ళు చదువుతారు. అలాగే పెట్టేశారా ఆల్రెడీ? ఎక్స్ప్లెనేషన్ వాడు రాయడం ఉంది, ఎక్స్ప్లెనేషన్ అయిపోయింది, వాడు రాయడం ఉంది ఇంకంతే. చెప్పండి సార్, ఎలా రాయాలో చెప్పండి సార్. అంతేనా? Take out your notes, everyone. Take your notes, write the question. Explain explain pat trees, explain pat trees and functional diagram, explain pat trees and functional diagram, and functional diagram of pat tree. ఇది ఫస్ట్ యూనిట్లో డాక్యుమెంట్ లో సిగ్నేచర్ ఎక్కడ ఉంది ఇబ్బంది ఏం లేకపోవచ్చు, కాసేపు చూద్దాము సార్. ఆడికి వచ్చేసాడు కదా, ఆడికి కొంచెం ఒక ఐడియా వచ్చింది అంటే ఎట్లా వస్తుంది. థర్డ్ వాళ్ళకి రాష్ట్రంలో ఉంది మేడం. ఫస్ట్ పార్టే కదా వాళ్ళకి కావాల్సింది. ఫస్ట్ పార్ట్ ఆల్రెడీ ఉంది. ఫస్ట్ ట్రై చేయండి మేడం. నేను పెట్టాను కదా నిన్న గ్రూప్లో. రాని అంటే దాని తర్వాత మనం కావాలి. మీరు నోట్స్లో చదివినా పర్లేదు, మీరు అక్కర్లేదు. ఎందుకంటే వాడు అక్కడ సెర్చ్ చేసిన తర్వాత ఇక్కడికి వస్తుంది ఆటోమేటిక్గా, ఆ కాన్సెప్ట్ ఇక్కడ మన రాష్ట్రాలకు వస్తుంది. వాడిని చూసి అప్పుడు ఓకే ఇదే కదా అని చెప్పేసి రాస్తారు. కొంచెం టైం సేమ్ రాయదు సార్. సార్